What do you think about our universe? Is our universe infinite or finite? It is true that our current knowledge and understanding cannot tell us whether this universe is finite or infinite. But still, if we engage in a thought experiment in our minds and want to know whether our universe is finite or infinite, it would be something like this. We don't think of this universe as infinite because if it were infinite, it means what has expanded throughout the entire space is only our universe. And some questions arises, like what about other universes where different physical laws or rules operate, distinct from those in our universe? Do they not exist, but we exist? Or do they exist in a place even larger than infinity? It's challenging to say that whatever space or cosmos exists, only our universe has expanded there. This doesn't seem accurate. On the other hand, if we consider that our universe is finite, the question arises, can there be something beyond this finite universe? The multiverse theory reveals the existence of other universes with different physical laws, and they exist in the multiverse like bubbles. This theory indicates the existence of every possible universe that could exist. In this multiverse, each universe appears like a bubble and feels finite, but a universe that is infinite would spoil this multiverse theory, no matter how infinite the multiverse itself may be. If every universe in the multiverse is like a bubble, then there must be a bubble that extends to infinity, and that bubble which is infinite and is also within this infinite multiverse. This situation breaks the theory. If you have read about the infinite hotel paradox, you would know that it's not possible to contain two infinite entities within each other. If we try to do so, it can lead to a breakdown. As you can see, the infinite multiverse theory can be break. Whether the universe is finite or infinite, the question arises. Do we have a space where we can accommodate both types of universes? Do we have a concept or a space larger than infinity that can contain infinity within itself, without breaking, no matter what we add to it? The concepts we've embraced to understand the universe certainly expand our knowledge and understanding, but are they sufficient to paint the complete picture? How vast is the concept of infinity? Is it capable of containing everything? What are the limitations of these conceptual entities? What is time? What is the true nature of dimensions? And is there truly a space that can contain everything? Answers to such questions are not currently known to anyone, but we move forward with answers to these very questions that you will learn about onward. Throughout history, we've encountered many puzzles that point to the idea of infinity, like Zeno's well-known dichotomy paradox or the arrow paradox that tells us that any object never reaches its end when divided. Not just Zeno, even in ancient India, mathematical texts like the Yoga Sutras discuss the concept of the infinite and the infinitesimally small. The simplest way to grasp the concept of infinity is through a number line that extends endlessly. A number line begins at 0 and can go up to infinity. When you apply the concept of addition, you'll notice that after adding 1 to 1, you get 2, and after adding 1 to 2, you get 3. We can keep adding 1 to the last number, and it continues indefinitely, or we can say it goes on to infinity, making the numbers infinite. What's special about numbers is that they not only help us counting numbers, but also help us count any entity like fruits, chapters, stars, or even dimensions like length, breadth, and height. Since numbers can extend to infinity, we can infer that these entities can also be counted up to infinity, provided they have no end. The three-dimensional world, composed of length, breadth, and height, can potentially extend to infinity, indicating that any three-dimensional world has the capacity to be infinite. Not only can you add, but you can also subtract to identify what is smaller, 1, which we consider smaller than 0. This illustrates that infinity encompasses the smallest to the largest, implying that infinity can encompass everything within it. But it's not its true nature, and you will know about its true nature onward. Any number line starts from 0, and after an equal intervals or measurements, we place numbers. Through the concept of addition, we understand that we can keep adding the numbers to the number line, and the number line can go up to infinity. This concept can be applied in the real world as well. For example, whenever we construct a building, we add bricks of the same measurement at an equal interval 1 by 1. If we continue adding bricks to building provided in a space that has no end, then the building itself can become infinite. The awareness and knowledge of the concept of numbers with addition give born to concepts like infinity, where largest to even more largest entity can encompass. Numbers like 1 million, 1 billion, trillion, and many more encompass all of them within, and there is no number or entity that is not within infinity. And if we want to see whether even the smallest number is also encompassed within infinity, we need to apply the concept of subtraction with the concept numbers. Whenever we subtract 0 from 1, we get -1 as a result. We perceive -1 as smaller than 0 because the concept of subtraction works this way. We know that, after applying the concept of subtraction, whatever number we obtain is always smaller. For instance, when we subtract 3 from 1, we get 2, which is smaller than 3. Similarly, when we subtract 1 from 0, we get -1. Since we got 2 using subtraction in above example, and it was smaller than 3, similarly, when we subtract 1 from 0, we should get a smaller number, which is -1, and we thought of it as smaller than 0. But does subtraction truly give us a digit smaller than 1? Or is it our intuition? Because in my research, I discovered that the concept of subtraction comes to an end upon reaching 0. How? Let me show you. If you think about a number line and observe it carefully, you will notice that the line is equally divided by its center point, 0, from where the line can extend in 2 directions. When you apply the concept of addition and try add 1 to 1, you get 2, which lies on the right-hand side of the number line. Apply the concept again, and you will see that the more you add numbers, the greater they become, and the distance from 0 or its center point also increases. If you apply the concept of subtraction, you will see that you always get a smaller number, and the concept of subtraction brings you closer to 0, or starts moving you to the left-hand side. You will also observe the same effect if you try adding numbers on the left-hand side of 0. For example, if you add -1 to -1, you get -2, and the number becomes more negative, and the concept of addition takes you away from 0. Conversely, in subtraction, you will see a similar result as we observe on the right-hand side. It will bring you closer to 0. In case you swap the sides or remove the sign, you will never be able to determine which side represents the bigger or smaller entities. Here, you can clearly see that concept of addition will take you away from 0 and towards greater values, while the concept of subtraction will bring you closer to 0 and towards smaller values. You will also observe that as soon as these concepts change the side or surpass 0, their working direction changes accordingly. The concept of addition, which was taking us towards the right-hand side now, upon reaching the other side of 0, is taking us towards the left-hand side. Similarly, with the concept of subtraction, when you apply it to numbers on the left-hand side, it takes us towards 0, moving toward right-hand side. The concept we were operating on, thinking that it would give us a smaller or larger number, changed its working direction as soon as we moved to the other side. And as we were thinking that we would get a smaller number, nothing like that happened. Instead, we observed that if we keep applying the concept of addition, it has no end on both sides of the line. However, with the concept of subtraction, after reaching 0, it comes to an end, and upon surpassing 0, its working direction is also towards 0. So does this mean that the concept of subtraction doesn't give us any number smaller than 0, but rather it ends after reaching 0? And if yes, then what is smaller than 0? And what about our idea that 1 is smaller than 0? Wouldn't it make more sense to consider that 1 is the opposite of 1? 1 is the opposite of 1 rather than being smaller than 0. Because as soon as we reach 0 in the concept of subtraction, it comes to an end. So how can we get anything smaller than 0? In a Knono space, for something to exist, we need a base entity. Along with the base entity, we also require something to rest upon for its proper existence, and we refer to it as a block entity. The base entity exists in a lower dimension or in 0 dimension compared to the dimension of our block entity. We also need to know the dimension of block entity in which it is operable, and after elucidating the dimensions of the block entity, we need to understand its nature and the working principles it can operate on. As you can see, in this 1D number line, the base entity was 0, from which the line starts. We placed a block, 1, or we can say we placed our block entity on it. Since this one-dimensional number line has 2 working directions, and we can place 1 only in one direction, we have to place 2 block entities, 1 on the right-hand side of the number line and 1 on the left-hand side of the number line. What we put on the right-hand side of number line is 1. Similarly, for the other side, we have to put something that has a proper existence and can be counted similarly as 1. However, because we have used 1 already, and due to our limited knowledge about these concepts, we mistakenly put -1, which modifies the concept of 1D number line and the equations we use, and also changes how we perceive the one-dimensional number line. We previously mentioned that the block entity has its nature, and how it behaves is determined by its working principle, or the concept to which it can respond. The nature of this block entity, coupled with its working principle or the concept like addition and subtraction, is to either increase or decrease until it's applicable, and as long as it doesn't lose its significance. The same holds true for the entity of opposite side of the number line, because both are same. Whatever is happening, we refer to it as the Shakti of any entity. If someone asks you that, what happened when we annihilate or subtract 1 from 1? You will say that we get 0. But I say that we obtain a base from which we can rebuild the number line in this Knono space. We don't have to revisit to understand that. From where did that 1 came from, or the concept like counting? We know that 1 can be said to anything that is self-contained and proper in itself. And also because this entity, 1, can be added or further counted, it leads us to the discovery of concepts like addition, subtraction, and many more. Long ago, we knew about the concept of 1, but we didn't know if anything could go smaller than 1. With Brahmagupta's discovery, we learned about 0, and before this revelation, we didn't know what was smaller than 1. Today, however, a similar situation has arisen where there is a misconception in determining what is smaller than 0. Some individuals have mistakenly asserted that -1 is smaller than 0. But this is not true, and I have demonstrated this above. The idea that -1 is smaller than 0 is incorrect and misguides us in pondering what is smaller than 0. Here, I'm not saying that it's wrong, but what I want to say is that it doesn't provide the answer we are searching for in its place, because it presents the concept of 1 from a different perspective. But don't worry, I am here to tell you the truth about what is smaller than 0, and that is the Knono space. Maybe you haven't heard about the concept of the Knono space, because it is. My concept, developed after extensive research, providing the most accurate and precise knowledge about any entity. The Knono space contains all dimensions and entities within it, but is still smaller than any entity, like 0. It can encompass entities larger than any other, and even more vast concepts than fundamental concepts like addition or subtraction, and it is truly expansive. However, if you focus solely on one aspect and believe that you can grasp all the knowledge about the Knono space, it may not be worth it. If you think that understanding the proper concept, like the number line, to comprehend the Knono space, then you may miss the bigger picture. You will undoubtedly learn more about the Knono space in the upcoming video. And after gaining awareness about everything and after understanding their proper meaning and realizing their limitations, you will have a comprehensive understanding of it all.